Hey everyone, and welcome back for another deep dive. Today we're taking a closer look at something pretty fundamental in Rust, structs.
Yeah, these are really interesting. At first glance, they might seem kind of basic.
Like just another data structure.
Right, exactly. But I think as we dig in a little deeper, we'll see that they're really a lot more than that. They're kind of this core building block for creating really well-organized and powerful Rust code.
Okay, so not just like a container to throw data into, there's some deeper magic happening here.
Definitely some magic. I think one of the best things about structs is they really encourage you to think about your data in a structured way.
Okay, so walk me through it. What's the big picture here? Why are structs so important in the Rust world?
Well, think about it this way. When you're building any kind of software, you're dealing with data, right? Lots of different pieces of information.
Customer names, order numbers, product prices, all that fun stuff.
Exactly. And without some way to organize that data, it can quickly become a real mess.
Code becomes difficult to read, bugs creep in, and suddenly you're spending hours trying to figure out what's going on.
Exactly. Structs give you this elegant way to group related pieces of data together.
Okay, so instead of having all this data floating around in chaos,
Yeah.
we can create these neat little packages.
Exactly. It's like having a well-organized toolbox where each tool has its own specific spot.
And Rust actually gives us a few different types of structs to play with, right? Named structs, tuple structs, and what were those other ones called?
Unit structs.
Right, unit structs. Those always sounded a bit mysterious to me.
Yeah, we'll definitely unpack those. But let's start with the most common type name structs. These are all about clarity and readability.
So in a name struct, each piece of data has a specific label and a type.
Exactly. It's like creating a form with clearly labeled input fields. You might have a struct called person with fields like name, which would be a string.
Age, which would be a number.
Right. And maybe occupation, another string.
So it's not just a jumble of data. Each piece has meaning and context.
Precisely. And this makes your code way easier to understand, both for yourself and for anyone else who might be working on it.
It also helps prevent those annoying errors where you accidentally try to use data in the wrong way, right? Like trying to do math with someone's name instead of their age.
Exactly. The compiler can catch those kinds of mistakes early on because each piece of data has a defined type. Okay, so we talked about name structs. Now, what about tuple structs?
These are the more compact ones, right? Where the data's meaning comes from its position rather than a specific name.
Exactly. They're like those multi-compartment containers you use for travel. You know what goes where based on the compartment's position.
So you might use a tuple struct to represent coordinates on a map. The first element is latitude, the second is longitude. No need to label them explicitly.
That's a great example. Tuple structs are perfect for situations where the meaning is clear from the context. All right, now for the mysterious unit structs.
The empty containers. What's the deal with those? Why would you create a struct with no data?
Well, think of unit structs as markers or signals. They don't hold any data themselves, but they represent a specific state or concept.
It's like raising a flag to indicate something without needing to shout it out loud.
Precisely. You might use a unit struct to represent something like a success or failure state in your code.
So instead of returning a Boolean value, like true or false, you could return a unit struct called success or failure.
Exactly. It adds a level of clarity and expressiveness to your code. It's all about conveying information in a clear and concise way.
I'm starting to see how these different struct types can be incredibly powerful tools for organizing and managing your data in Rust. They seem pretty straightforward on the surface, but there's a lot of thoughtfulness baked into how they work and how they interact with other concepts in the language.
Definitely. And as we delve deeper, we'll see how these simple building blocks can create really sophisticated and robust applications. It's all about laying a strong foundation with well-organized data. All right, so we've talked about how structs help us organize data, but what about actually using that data? Like once it's tucked away neatly inside a structure, how do we get to it?
Right, we don't want our data to just be trapped in these little containers forever.
Exactly. That's where destructuring comes in. It lets you unpack a struct and easily access its individual components.
Okay, so it's like opening up that well-organized toolbox and pulling out the specific tool we need.
Exactly. And there's this really cool technique in Rust called pattern matching that works hand in hand with destructuring.
Pattern matching. I've heard that term thrown around. It sounds powerful.
It is. Pattern matching lets you write code that adapts based on the shape of your data. Like imagine our person struct again. You could use pattern matching to say, if this person's age is over 21, they can do this, otherwise do that.
So it's not just taking the struct apart, but making decisions based on what's inside.
Exactly. It's like having a smart toolbox that knows which tools you need for a particular task. Keeps your code clean and efficient. And speaking of making our structs smarter, let's talk about methods.
Methods, like those functions that are attached to a struct.
Precisely. They give our custom data types superpowers.
So instead of having these loose functions floating around, we can define behavior that's specific to a struct.
Exactly. It's all about keeping things organized and making sure our code is easy to understand. Like if we have a rectangle struct, we could define a method called calculateria.
So the rectangle can calculate its own area. That makes a lot of sense.
Right. It keeps everything neat and tidy. And just like we have different types of structs, we also have different types of methods.
Like instance methods that operate on a specific instance of a struct.
Right. And associated functions that are more like general utilities related to the struct, but not tied to any particular instance.
So instance methods are personalized actions, while associated functions are more like shared tools.
Exactly. Rust gives you a lot of flexibility here. Okay, so we've talked about different types of structs, how to access their data, and how to attach actions to them with methods. What else? We can't forget about two crucial concepts in Rust: ownership and borrowing. Ah, yes, these are fundamental to how Rust manages memory and ensures safety, and they apply to structs just like any other data type.
So if a struct owns its data, it's like having the master key, right?
Yeah.
No one else can touch it without permission.
Exactly. And if you move that struct to another part of your code, ownership is transferred along with it. No risk of data being deleted while someone else is still using it.
Like handing over the keys to your car. Whoever has the keys is responsible. And borrowing is like letting someone borrow your car. They can use it, but they don't own it.
Perfect analogy. And Rust's borrowing rules are super strict. You can't accidentally modify data while someone else has a borrow. Prevents those nasty crashes that happen in other languages.
So ownership and borrowing are like these built-in guardians that keep our data safe and sound, especially when we're dealing with the complexities of structs.
Absolutely. And these concepts become even more important when we start talking about concurrency, where multiple parts of your code are running at the same time.
Oh, that's a whole other can of worms. But for now, I think we've got a pretty good handle on the basics of structs.
Definitely. We've covered a lot of ground here, but there's one more thing I want to touch on before we wrap up.
Okay, what else is there to know about these amazing structs?
Well, we've talked about adding behavior to structs with methods, but what if you need to create copies of your structs? That's where the copy and clone traits come in, and they play a critical role, especially when structs own the data.
Copying data. I can already sense that there's some potential for trouble there if it's not handled carefully.
You're right, there are definitely some subtleties involved. Both copy and clone deal with creating duplicates, but they work in slightly different ways. Understanding the difference is key when working with structs in Rust.
Okay, so copy and clone, two ways to duplicate our structs. What's the difference?
Well, think about it this way. Copy is like making a photocopy. You get an exact replica, but it's super lightweight. No extra effort needed.
So it's fast and efficient, but I'm guessing there are limits to what types can be copy, right?
Exactly. Copy only works for types that have a fixed size and don't have any complex behavior when they're copied, like integers, booleans, those sorts of things.
So things that are just values, no strings attached.
Yeah.
But what about more complex types? That's where clone comes in.
Precisely. Clone is for those heavier duty types that might have internal structures or own resources. When you clone something, you're creating a truly independent copy.
So it's like building a whole new house versus just making a blueprint.
I like that analogy. Copy is the blueprint, clone is building the actual structure.
Right.
And when we're talking about structs that own data, clone becomes super important.
Because if a struct owns data like a string, simply copying the struct wouldn't copy the data itself, right? We just have two structs pointing to the same data.
Exactly. And that can lead to all sorts of problems. But with clone, you get a brand new copy of the data as well. Each struct owns its own set of data, nice and clean.
So copy and clone aren't just about duplication. They're about making sure our structs play nicely with Rust's ownership system, keeping everything safe and sound.
You got it. They're like the guardians of data integrity, making sure everything stays organized and predictable.
This has been an incredible journey into the world of structs. We started with these simple data containers and uncovered so much complexity: immutability, destructuring, methods, ownership, borrowing, and now copy and clone.
It's amazing how much power is packed into this one seemingly simple concept. Structs are the foundation for building well-structured, robust Rust code.
And for all our listeners out there, don't stop here. There's a whole world of advanced techniques built upon these foundations. Things like generics and traits, which we could spend a whole deep dive talking about.
Absolutely. Rust's focus on safety, efficiency, and expressiveness really shines through in how structs are designed and used.
So keep experimenting, keep learning, and keep diving deeper into the world of Rust. Thanks for joining us.